All right, let's look at the homework 11.8, problem number 7. All right, so let's find the radius of convergence and the interval of convergence here. All right, so I'm going to do a ratio test on this guy again. So ratio test. And especially when you have factorial, ratio test is very effective. So you do a limit as n approaches infinity. Then here, so you have n factorial, so I'm going to put the n plus 1 factorial. And then you have x to the n plus 1 over 5, 11, 17, and so on. 6n minus 1. Right? Then we want to divide by an, so we just have to take the reciprocal. So you have n factorial, x to the n. Then you have a 5. Oh, actually, I forgot to add one more. So this is the next one would be 6n plus 5. Right? And sorry about that. And then you have a 5 times 11 times 17 times all the way to 6n minus 1. All right. Then we can do cancellation. So you have a 5, 5, 11, 11, 17, 17, all the way to 6n minus 1, 6n minus 1. Then you have an n factorial, and there's n plus 1 times n factorial, so I get rid of that. And x to the n, so you have another x left over. All right, then what you get is going to be here. This is going to be equal to, right? So absolute value of x, and that has nothing to do with the n, so we have that. And the only thing that's left is n plus 1 here and 6n plus 5 there. All right, so you have a limit as n approaches infinity. All right, so you have n plus 1 on top and over and 6n plus 5. All right, then we don't really need the absolute value sign. So here, I'm going to do a L'Hopital's rule here. So this is going to be absolute value of x, and L'Hopital's rule, n approaches infinity. Derivative of n plus 1 is 1. Derivative of 6n plus 5 will be 6. So this is going to be just absolute value of x over 6. And this, we want this to be less than 1. All right. To find the radius of convergence, I'm going to multiply by 6. So we have absolute value of x is less than 6. All right. Then we put that in there. So we have radius of convergence is 6. All right. Then what we want to do is we want to look at the endpoints here. All right. So let's see. Hold on a sec. All right, so we're going to turn this into an interval. So x is between -6 and +6. All right, so let's check the left endpoint. All right, so when x is equal to -6, so what do we get? All right, so x is -6, so you have summation. N goes from 1 to infinity. Then you have a n factorial. And you have a -6 to the n over. And then we have 5 times 11 times 17 times and so on. and 6 n minus 1. Alright, so let's try a divergence test on this guy. Alright, so let's think about doing, let's see. I'm going to actually put the negative one separately, so let's do it this way. Alright, so I'm going to write an as here, negative 1 to the n. Alright, so that's outside. Alright, so n factorial is n times, so then you have times 6, so you have n times 6, so 6n, right? And times n minus 6 times n minus 1, and 6 times n minus 2, and so on, and you have 6. Right, so if you compare this with this guy, let's see, 5 times, and the next one would be 12, and 11 times 17 times and so on, and 6n minus 1. And if you write it this way, you notice that here, this guy is actually getting, so you have a 6 over 5 times 12 over 11 times, so next one would be, let's see, 18 over 17 times, and so on, and 6 over 6n minus 1. Alright, and if you take the absolute value of this guy, so that I don't have to worry about this, negative 1 to the n power thing, right? Then you notice that this guy is, look, 6 over 5, right? This is 12 over 11, so this is bigger than 1. 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 So this is actually greater than 1, right? Which means that if you take the limit, this is going to be greater than 1, which is never 0, right? Which means that it fails the divergence test. So here, maybe it means that limit of n approaches infinity of an does not exist, which means that it's divergent because of the divergence test. All right, and the right endpoint is very much the same. All right, only difference is that you don't have a negative sign, so you get exactly the same thing. So an is going to be 6 over 5 times 12 over 11, and so on, to 6n over 6n minus 1. All right, so this is greater than 1, which means that the limit of an as n approaches infinity is greater than 1, which is not equal to 0. So it's going to be divergent, right? Which means that we exclude negative 6, and we also exclude positive 6. All right, let's type it in. All right, radius of convergence is 6, and the interval is negative 6 to 6. All right, let's check the answer, submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.